The morning fog hung thick over Norfolk Naval Shipyard as Captain Sarah Martinez stood on the deck of the USS Constellation, staring down at what should have been impossible. The massive guided missile cruiser, one of the Navy's most advanced vessels, sat dead in the water with her main propulsion system completely offline. What made the situation even more frustrating was that nobody could figure out why. "Status report," Captain Martinez called to Commander Jackson, her chief engineering officer, who approached with a tablet clutched in his sweating hands. "Ma'am, we've had Northrop Grumman's top engineers working on this for 6 days straight. The propulsion control system just won't respond. Every diagnostic shows green across the board, but the engines won't start. It's like the computer is speaking a different language than the hardware." Captain Martinez frowned. The Constellation was scheduled to deploy to the Mediterranean in 10 days as part of a crucial NATO exercise. Billions of dollars in military coordination depended on her ship being operational. The political implications of missing this deployment would ripple all the way to Washington. What about General Dynamics? They built the original control systems. "Already here, Captain. 3 of their senior systems engineers arrived yesterday from Groton. They're as stumped as everyone else. They keep saying the computer interface should work perfectly with the engine management system, but something is blocking the communication." The captain walked to the bridge wing and looked down at the pier, where a small army of contractors, Navy technicians, and civilian experts had set up what looked like a temporary computer lab. Cables snaked everywhere, diagnostic equipment hummed constantly, and frustrated engineers huddled around laptops displaying endless streams of code and system readings. Dr. Rebecca Chen from Northrop Grumman was arguably the smartest person currently aboard the ship. She held 2 PhDs in electrical engineering and computer science from MIT and had designed control systems for everything from nuclear submarines to space shuttles. She had been working 18-hour days trying to crack the problem. "The integration protocols are perfect," Dr. Chen explained to the gathered team of experts during their daily briefing in the ship's conference room. "I've personally verified every line of code in the propulsion management software. The hardware diagnostics show all systems functioning normally, but when we send the startup command, it's like the engines simply don't hear it." Lieutenant Commander Pete Williams from the ship's engineering department raised his hand. "Could it be a hardware problem that's not showing up on diagnostics?" "We've physically inspected every connection, every relay, every circuit board," replied Jim Rodriguez from General Dynamics. "I've been working on these systems for 15 years. I know them better than I know my own car. The hardware is fine." The room fell silent. Outside, seagulls cried and the sounds of normal shipyard activity continued. But inside the conference room, frustration was thick enough to cut with a knife. Captain Martinez stood up. "Ladies and gentlemen, I need options. In 4 days, I have to report to Admiral Thompson about our deployment status. The Secretary of Defense is personally tracking this mission. We cannot fail." Dr. Chen pushed her glasses up her nose and looked at her notes. "Captain, we've explored every possibility we can think of. The system architecture is sound, the software is clean, the hardware tests perfect. I hate to say this, but we might need to consider completely replacing the entire propulsion control system." "How long would that take?" Captain Martinez asked, though she already suspected the answer would be unacceptable. "Minimum 8 weeks, Jim Rodriguez answered, "and that's if we can get priority production slots for the custom components. More likely 12 to 16 weeks. The captain sat back down heavily. Missing the NATO exercise would be a black mark on her record that might end her career. More importantly, it would signal weakness to allies who were counting on American naval power to maintain stability in an increasingly volatile Mediterranean region. "There has to be another way," she said quietly. Commander Jackson cleared his throat. "Ma'am, there might be one option we haven't explored." Everyone turned to look at him. "Go on," Captain Martinez said. "My uncle mentioned a guy he served with back in the day. retired Navy Chief Petty Officer named Tom Sullivan. He worked on the original integration team when the Navy first started computerizing ship engines back in the early 2000s. According to my uncle, this guy could make any computer talk to any engine, no matter how incompatible they seemed. Dr. Chen looked skeptical. "Commander, no disrespect to your uncle's friend, but this is cutting-edge technology. We're dealing with quantum-encrypted communication protocols and AI-assisted diagnostics. This isn't something you can fix with old-school mechanical knowledge." "Maybe not," Commander Jackson replied. "But what we're doing isn't working either, and frankly, we're running out of time and options." Captain Martinez drummed her fingers on the table. Bringing in some retired Navy mechanic would look desperate. If word got back to Admiral Thompson that she was bypassing the Navy's contracted experts in favor of some old-timer, it could damage her reputation even more than missing the deployment. But then again, she was already facing career-ending failure. What did she have to lose? "What do we know about this Tom Sullivan?" she asked. Commander Jackson pulled out his phone. "I can call my uncle right now and get details. He speaks very highly of the guy. Says Sullivan was legendary for solving impossible problems during his 30 years in the Navy. Where is he now?" "I think he runs a small boat repair shop somewhere in Virginia Beach. My uncle could probably get his contact information." Dr. Chen looked around the room with obvious frustration. "Captain, I really think we should focus on technical solutions. No offense to this retired sailor, but modern naval systems are incredibly complex. Unless he's kept up with current technology, I don't see how he could help." Jim Rodriguez nodded in agreement. "Dr. Chen is right. These control systems require specialized training and certification. We can't just have anyone poking around in million-dollar equipment." Captain Martinez studied the faces around the table. These were brilliant people, experts in their fields, and they had exhausted their knowledge trying to solve this problem. Traditional approaches weren't working. Maybe it was time to try something untraditional. "Commander Jackson, call your uncle. Get me Tom Sullivan's contact information. I want to speak with him today." "Yes, ma'am." As the meeting broke up and the experts headed back to their diagnostic equipment, Captain Martinez remained in her chair, staring out the porthole at the busy shipyard. In her 20-year Navy career, she had learned that sometimes the most impossible problems required the most unexpected solutions. 3 hours later, Commander Jackson knocked on her cabin door with a piece of paper in his hand. "Captain, I spoke with my uncle and got Tom Sullivan's information. Turns out he lives just 40 minutes from here. My uncle says he'd be willing to take a look at our problem, but he wants to know what we've already tried." Captain Martinez looked at the paper with Sullivan's phone number written in Jackson's neat handwriting. This could be the biggest mistake of her career, or it could be exactly what they needed. She picked up her phone and dialed the number. "Sullivan Marine Repairs, this is Tom." "Mr. Sullivan, this is Captain Sarah Martinez, Commanding Officer of the USS Constellation. I understand you might be able to help us with an engineering problem." There was a pause on the other end of the line. "Well, Captain, that depends on what kind of problem you're having. I work mostly on fishing boats and pleasure craft these days." Captain Martinez took a deep breath. "Mr. Sullivan, we have a situation that our best engineers can't solve. I'm told you have experience with ship computer systems." "I've worked on a few in my time. What seems to be the trouble?" "Our main propulsion system won't respond to computer commands. All diagnostics show everything is working perfectly, but the engines simply won't start. We've had teams from Northrop Grumman and General Dynamics working on it for nearly a week with no success." Another pause, longer this time. "Captain, that sounds like what we used to call a ghost problem. Everything looks right on paper, but something's not talking to something else." "Exactly." "Are you familiar with current naval propulsion control systems?" Tom Sullivan chuckled. "Well, I helped design and install the first generation of computerized engine controls for the Navy back when everyone thought putting computers on ships was crazy." I've kept up with developments over the years. Maritime electronics are kind of a hobby of mine. Captain Martinez felt the first spark of hope she'd experienced in days. Mr. Sullivan, would you be willing to come take a look? I know it's asking a lot, and I can't promise anything, but we're desperate. Captain, I'd be honored to help if I can. When would you like me there? How about right now? Tom Sullivan laughed. Give me an hour to close up the shop and grab my tools. I'll be there before sunset. As Captain Martinez hung up the phone, she realized she had just made a decision that would either save her career or end it completely. But something about Tom Sullivan's calm confidence made her believe she might have found the right person for the job. She looked out her porthole again at the teams of experts still working frantically on the pier below. In 1 hour, everything might change. Tom Sullivan pulled his 15-year-old Ford pickup into the Norfolk Naval Shipyard gate just as the sun began to set behind the massive cranes and dry docks. The security guard looked skeptical as he examined the work order that Captain Martinez had arranged, but eventually handed back Sullivan's identification and waved him through. At 72 years old, Tom Sullivan looked more like someone's grandfather than a naval engineering expert. His white hair was thinning. His work clothes were clean but well worn, and he carried his tools in a battered leather bag that had seen better days. As he walked up the gangplank of the USS Constellation, several of the contractor engineers barely glanced at him. Captain Martinez met him at the quarterdeck, accompanied by Commander Jackson. She had expected someone younger, more polished, perhaps wearing a suit and carrying high-tech diagnostic equipment. Instead, she found herself shaking hands with a man who looked like he belonged in a small-town garage. Mr. Sullivan, thank you for coming on such short notice. Happy to help, Captain. It's been a while since I've been aboard a ship this size. She's beautiful. Commander Jackson led them toward the engine room. Mr. Sullivan, I should warn you that we've got some very frustrated engineers down there. They've been working around the clock and haven't made any progress. Tom Sullivan nodded. I understand. Nobody likes having their work questioned, especially by an outsider. I'll try to stay out of their way while I get oriented. As they descended into the ship's engineering spaces, the complexity of the modern naval vessel became apparent. Unlike the ships Tom had worked on during his Navy career, the Constellation was filled with computer monitors, digital displays, and electronic systems that would have been science fiction 30 years ago. Dr. Chen looked up from her laptop as the three of them approached the main propulsion control station. Her expression was polite but clearly skeptical. Dr. Chen, Captain Martinez said, this is Tom Sullivan. He's going to take a look at our problem. Dr. Chen stood and extended her hand. Mr. Sullivan, I understand you have experience with naval engineering systems. Some, Tom replied modestly, though I suspect things have changed quite a bit since my time. They have, Dr. Chen said. These control systems use AI-assisted diagnostics, quantum-encrypted communications, and distributed processing across multiple network nodes. The complexity is several orders of magnitude beyond older systems. Tom Sullivan walked over to the main control console and studied the displays showing countless green status lights and streaming data. Mind if I ask what you've tried so far? Dr. Chen exchanged a glance with Jim Rodriguez from General Dynamics before answering. We've verified all software, replaced suspected hardware components, tested every communication pathway, and even brought in a completely new control computer. Everything tests perfectly, but the engines won't respond to startup commands. Interesting, Tom said, pulling a small notebook and pen from his shirt pocket. Has anyone looked at the timing protocols? Timing protocols? Jim Rodriguez stepped forward. Mr. Sullivan, these are modern digital systems. Timing is handled automatically by the system architecture. We don't have to worry about synchronization issues like in the old analog days. Tom nodded and made a note. Of course. What about power supply variations? Even tiny fluctuations can cause communication problems. Dr. Chen pulled up a screen full of power monitoring data. We've monitored power quality constantly. Everything is well within specifications. For the next hour, Tom Sullivan asked questions that the engineers considered basic or irrelevant. He asked about grounding systems, cable routing, electromagnetic interference, and even the ship's location relative to nearby radio transmitters. The experts answered patiently, but with increasing frustration. "Mr. Sullivan," Dr. Chen finally said, "I appreciate your interest, but we've already investigated all of these fundamental issues. This is clearly a sophisticated software integration problem that requires advanced diagnostic techniques." Tom Sullivan closed his notebook and smiled. "You're probably right, Doctor. I'm just trying to understand how all these pieces fit together. Mind if I spend some time looking around on my own? Sometimes fresh eyes can spot things that others miss." Captain Martinez nodded. "Of course. Commander Jackson will stay with you and provide any assistance you need." As the group of experts returned to their computers and diagnostic equipment, Tom Sullivan began a methodical examination of the engineering spaces that surprised Commander Jackson with its thoroughness. Unlike the contractors who focused on computer screens and electronic readings, Tom physically traced cable runs, examined junction boxes, and studied the actual hardware installations. "Mr. Sullivan," Commander Jackson asked, "what exactly are you looking for?" "I'm trying to understand the complete signal path from the control computer to the engines. Sometimes the problem isn't in the smart parts of the system. It's in the simple connections between the smart parts." They spent 2 hours crawling through cable runs, examining connectors, and following wire paths through the ship. Tom took careful notes about routing, shielding, and the physical relationship between different systems. "Commander," Tom said as they paused near a large electrical panel, "when was the last major maintenance work done on this ship?" Jackson consulted his tablet. "We had a major electronics upgrade 6 months ago. New radar systems, updated communications equipment, and improved network infrastructure. Was any work done near the propulsion control systems? I'd have to check the maintenance records, but I think there was some cable rerouting to accommodate the new equipment." Tom Sullivan made another note. "Could you get me those records? I'd like to see exactly what changes were made." While Commander Jackson retrieved the maintenance files, Tom continued his examination. Near the main propulsion control junction box, he noticed something that made him pause and look closer. The main control cables ran through a metal conduit that passed very close to a large bundle of power cables that hadn't been there in the original ship design. The power cables were part of the new radar system installation and carried high-frequency switching currents that could generate electromagnetic interference. Tom pulled out a small handheld device that looked ancient compared to the sophisticated diagnostic equipment the contractors were using. It was a simple electromagnetic field detector that he had modified over the years for troubleshooting electrical problems on boats. As he held the device near the control cable conduit, it began beeping rapidly. "Commander Jackson," Tom called softly, "could you ask Dr. Chen to send a startup command to the engines?" Jackson radioed the request, and moments later, Dr. Chen's voice came back over the radio. "Command sent. No response as usual." Tom's field detector went crazy during the few seconds of the startup sequence, showing massive electromagnetic interference exactly when the control computer was trying to communicate with the engines. "Commander, ask her to send the command again, but this time ask someone to turn off the main radar system first." "Turn off the radar? Mr. Sullivan, that's a pretty big request. Ships don't normally operate without radar." "Just for a few minutes to test a theory." Commander Jackson made the request, and after some discussion with Captain Martinez, the radar system was shut down. Tom's field detector showed normal readings. "Now ask Dr. Chen to send the startup command." There was a pause. Then Dr. Chen's excited voice came over the radio. "Commander, the engines are responding. All systems show normal startup sequence initiated." Commander Jackson stared at Tom Sullivan in amazement. "How did you know?" Tom smiled and pointed at the cable routing. 30 years ago, we had to be very careful about electromagnetic interference because our equipment was more susceptible. Modern equipment is better shielded, but it's not perfect. When they installed these new power cables for the radar system, they routed them too close to the control cables. The high-frequency switching in the radar power supply was creating interference that corrupted the control signals just enough to make them unreadable. Within minutes, Dr. Chen, Jim Rodriguez, and Captain Martinez were all crowded into the small equipment space, staring at Tom's simple field detector. "This is impossible," Dr. Chen said, shaking her head. "Our diagnostic system should have detected electromagnetic interference." Tom pointed to a computer display showing EMI readings. "Your system is looking for interference in the radio frequency spectrum. This interference is in a much lower frequency range that your equipment isn't monitoring. It's like having a conversation in a noisy room. You can hear fine until someone starts talking at exactly the same frequency you're using." Jim Rodriguez examined the cable routing with new understanding. "The startup sequence uses a specific frequency for critical timing signals. If that frequency gets corrupted, the engines hear garbage instead of commands," Tom finished. "Everything else works fine, because the other control frequencies aren't affected." Captain Martinez looked at the maze of cables and equipment surrounding them. "How do we fix this permanently?" Tom Sullivan pulled out a measuring tape and began examining the cable routes. "Several options. We can reroute either the power cables or the control cables to increase separation. We can add additional shielding. Or we can install filtering equipment to clean up the interference. The fix isn't complicated once you know what the problem is." Dr. Chen was quiet for several minutes, studying the interference readings and cable layouts. Finally, she looked up at Tom Sullivan. "Mr. Sullivan, I owe you an apology. We were so focused on the sophisticated aspects of the system that we overlooked basic electromagnetic compatibility." "No apology needed, Doctor. You know far more about these systems than I do. Sometimes it just takes a different perspective to see what's hiding in plain sight." Captain Martinez felt an enormous weight lifting from her shoulders. "How long will it take to implement a permanent fix?" Tom considered the options. "Rerouting cables would be the most thorough solution, but that could take several days. Adding shielding and filters could be done in about 8 hours if we can get the right materials." "Mr. Rodriguez, can General Dynamics provide the necessary components by tomorrow morning?" "Absolutely, Captain. We can have everything here by 0800. As the group prepared to head back topside, Dr. E. Chen approached Tom Sullivan privately. "Mr. Sullivan, I'm curious about something. How did you know to look for electromagnetic interference when our diagnostic systems showed everything was fine?" Tom smiled and patted his old field detector. "Experience, mostly. But also, I learned a long time ago that when computers say everything is perfect but things don't work, the problem is usually in the connections between the computers and the real world. Computers are very smart, but they can only see what they're designed to look for." Captain Martinez overheard this exchange and realized that Tom Sullivan had just taught all of them a valuable lesson about the difference between technical knowledge and practical wisdom. By 0600 the next morning, Norfolk Naval Shipyard was buzzing with activity that had nothing to do with the usual ship maintenance routines. Word had spread quickly through the naval engineering community that a 72-year-old retired chief petty officer had solved in 4 hours what teams of experts couldn't crack in a week. Tom Sullivan arrived at the pier carrying coffee and donuts from a local shop, looking completely unfazed by the attention his discovery had generated. Dr. Chen and Jim Rodriguez were already aboard with boxes of specialized shielding materials and filtering equipment, their earlier skepticism replaced by genuine respect for the old sailor's diagnostic skills. Captain Martinez met Tom at the gangplank with news that changed everything. "Mr. Sullivan, I've been on the phone with Admiral Thompson all morning. When I explained what happened here, he asked me to have you call him personally." Tom looked surprised. An admiral wants to talk to me? Captain, I just found a wiring problem. It's not that big a deal. Mr. Sullivan, it is a big deal. Admiral Thompson told me this same propulsion control problem has been reported on at least 6 other ships in the fleet. The Navy has spent millions of dollars bringing in contractors to investigate, and nobody has found the root cause. As they walked toward the engineering spaces, Commander Jackson joined them with a tablet full of maintenance records. Mr. Sullivan, I've been researching the timing of these problems. Every ship that's experienced this issue had major electronics upgrades in the past year. New radar systems, communication equipment, and network infrastructure. Tom stopped walking and considered this information. Same contractor for all the upgrades? Mixed contractors, but the work was all done according to the same Navy specifications for cable routing and system integration. Dr. Chen looked up from her equipment as they approached. Mr. Sullivan, I've been thinking about what you discovered last night. If this interference problem exists on multiple ships, it means there's a fundamental flaw in our integration standards. Tom set down his coffee and examined the cable routing diagrams that Dr. Chen had spread across a workbench. Doctor, modern ships have so many electronic systems that electromagnetic compatibility is more important than ever, but it seems like the installation standards haven't kept up with the complexity. Jim Rodriguez nodded grimly. The Navy specifications for cable separation were written 15 years ago. They didn't anticipate the power levels and switching frequencies of current radar and communication systems. Over the next 6 hours, Tom Sullivan worked alongside the contractor teams to implement a permanent solution. His approach was methodical and practical, testing each modification to ensure it didn't create new problems while solving the existing ones. The first step was installing specialized ferrite filters on the control cables to block interference in the specific frequency range that was causing problems. Tom insisted on testing each filter installation individually, using his simple field detector to verify that interference levels dropped as expected. Why not just install all the filters at once? Dr. Chen asked. Tom smiled patiently. Because if we make 6 changes at once and something goes wrong, we won't know which change caused the new problem. Better to make one change, test it, then move to the next. The second step was adding additional shielding around the most critical control cables. This required carefully opening cable conduits and wrapping the cables with specialized electromagnetic shielding material. Jim Rodriguez worked alongside Tom during this process and was impressed by the older man's attention to detail. Mr. Sullivan, you're treating these cables like they're fragile arteries. In a way they are, Tom replied. These ships are incredibly complex organisms. Every system depends on every other system. If you damage one small connection while trying to fix another problem, you can create failures that are worse than what you started with. By noon, the modifications were complete, and initial tests showed dramatic improvement in signal quality. Tom's field detector showed minimal interference even when all the ship's systems were operating at full power. Captain Martinez authorized a full system test, and for the first time in over a week, the USS Constellation's main engines started normally and responded correctly to all control commands. But Tom Sullivan wasn't satisfied yet. He spent another 2 hours running the engines through every possible operating scenario, monitoring interference levels and signal quality under different conditions. Mr. Sullivan, Dr. Chen observed, you're being very thorough. The system is clearly working now. Tom paused in his testing and looked at her seriously. Doctor, this ship is going into harm's way. The people aboard are depending on these systems to bring them home safely. Good enough isn't good enough when lives are at stake. Dr. Chen realized that Tom Sullivan's approach wasn't just about technical competence. It was about a level of personal responsibility that came from decades of naval service. By 1800 that evening, the USS Constellation was officially ready for deployment. Captain Martinez stood on the bridge as the massive ship's engines responded smoothly to navigation commands for the first time in over a week. Admiral Thompson arrived at Norfolk just as the final tests were being completed. He was a tall, imposing man who had commanded destroyers and aircraft carriers before taking his current position overseeing Atlantic Fleet operations. Tom Sullivan was cleaning his tools when Admiral Thompson found him in the engineering spaces. The Admiral studied the modifications that had been made, asked detailed questions about the technical solution, and reviewed the test results with the thoroughness of someone who understood both engineering and naval operations. "Chief Sullivan," Admiral Thompson said, using Tom's old Navy rank, "I need to ask you something. Would you be willing to help us solve this problem fleet-wide?" Tom looked up from his tool bag. "Admiral, I'm honored by the request, but I'm not sure what more I can do. The solution is pretty straightforward once you know what to look for." "Chief, that's exactly the point. You identified in 4 hours what our best engineers couldn't find in months of investigation. I want you to review the integration standards for electronic systems on Navy ships. We need someone who understands both the old principles and the new technology." Tom Sullivan had been enjoying his retirement, working on small boats and spending time with his grandchildren. But the idea of helping solve a problem that could affect the entire Navy fleet appealed to the sense of service that had never really left him. "What would you need from me, Admiral?" Admiral Thompson smiled. "I want you to work with our Naval Sea Systems Command to revise the electromagnetic compatibility standards for ship modifications. You'd also train teams of Navy technicians to recognize and solve these kinds of interference problems." Dr. Chen stepped forward. "Admiral, if I may suggest, Mr. Sullivan should also review the diagnostic procedures we use. Our sophisticated equipment completely missed this problem, but his simple field detector found it immediately." "Excellent point, Doctor. Chief Sullivan, what do you say? The Navy could use your expertise." Tom looked around the engineering space at the complex systems that kept modern warships operating. Then he thought about the other ships in the fleet that might be facing similar problems, and the sailors who depended on these systems. "Admiral, I'd be honored to help, but I have one condition." "What's that, Chief?" "I want to work with the existing engineering teams, not replace them. People like Dr. Chen and Mr. Rodriguez know far more about these systems than I do. My job should be to help them see problems from different angles, not to show them up." Admiral Thompson extended his hand. "Chief Sullivan, you just proved why you're the right person for this job. When can you start?" As the sun set over Norfolk Naval Shipyard, the USS Constellation prepared for departure. Captain Martinez stood on the bridge watching the controlled chaos of a ship getting underway, knowing that her vessel would make its scheduled deployment thanks to an unlikely combination of high technology and old-fashioned troubleshooting wisdom. 3 months later, Tom Sullivan's revised electromagnetic compatibility standards were adopted throughout the Navy. His training program had taught hundreds of Navy technicians to recognize interference problems that sophisticated diagnostic equipment might miss. Most importantly, the propulsion control failures that had plagued the fleet became a thing of the past. Dr. Chen often worked with Tom during this period and came to appreciate that true expertise wasn't just about knowing the latest technology, it was about understanding the fundamental principles that remained constant even as technology evolved. "Mr. Sullivan," she said one day as they finished reviewing modifications on another ship, "you've taught me that sometimes the most sophisticated solution is to ask the simplest questions." Tom smiled as he packed away his old field detector, which had become something of a legend in Navy engineering circles. "Doctor, I learned a long time ago that complex problems often have simple causes. The trick is being willing to look in places where smart people don't think to look." The USS Constellation completed her Mediterranean deployment successfully, earning commendations for both her operational performance and her system reliability. Captain Martinez was promoted to Rear Admiral 18 months later, and she never forgot the lesson she learned from a retired chief petty officer with simple tools and practical wisdom. Admiral Thompson established a new policy requiring that all major ship modifications be reviewed by teams that included both high-tech specialists and experienced Navy veterans. The policy became known informally as Sullivan's Rule, and it prevented countless engineering problems throughout the fleet. Tom Sullivan returned to his boat repair shop in Virginia Beach, but now he spent several days each month consulting for the Navy on complex engineering problems. He never charged for his services, saying that helping the Navy was simply an extension of the oath he had taken decades earlier. Years later, young Navy engineers would learn about the Constellation incident in their training, studying how a seemingly impossible technical problem was solved by someone who understood that the most important diagnostic tool wasn't sophisticated software or expensive equipment. It was experience, patience, and the willingness to examine every possibility, no matter how basic it seemed. The story became a reminder that in an age of incredible technological complexity, there was still no substitute for practical wisdom, attention to detail, and the kind of dedication that comes from understanding that other people's lives depend on getting the job done right.